So in this problem, we have what is the magnitude of the normal force exerted on the car by the walls of the circle at point B, which is the top of the circle. So we already predicted that at the top, it will actually be reduced than here. So here it will have the greatest normal force, because since it's almost it's on the ground, perpendicular to the ground. Gravity will be pushing down with all its force, and then since it's completely on the ground, the circle will be pushing with all its force up. But here, since it's on the ground and normal force is pointing down along with gravity, both gravity and normal force are pointing in the same direction. The normal force is going to be a lot less because gravity is doing most of the work. So I just rewrote all the information they've given us: 1.61 kilograms. That's what this weighs, the car. 12 meters per second, that's the speed it's going, and 5 meters, which is the radius. So for most physics problems, what you're gonna do is just draw a free body diagram, or just draw something in general. So here, all I drew was the actual car, and then right here, and then all I just said was I'm pointing down for gravity, and then it's supposed to be on the same place, but all it's meaning is there's another force, which is normal force, and that's also pointing down. This is not part of the free body diagram, but I'm showing that the acceleration is actually going to be negative, because we know that the acceleration has to point inward for it to keep moving in a circle. So if it's moving inward, it has to be pointing to the center. So that means if we put this on a x and y axis, it would actually be on the negative part of the y axis. And that will actually affect our answer. So now you can just use this method for most force problems. You have forces in the x direction and forces in the y direction. So for this problem, we actually don't have any forces in the x direction. There's nothing on the x-axis, so we don't even have to worry about it. So now you look, what's positive, what's negative? Well, here, the force is pointing down, so it's on the negative part of the y-axis, so that's going to be negative. Gravity is negative because it's pointing down on the y-axis. And then here, it's really important, the acceleration is not positive, it's negative. Because since it's pointing down, it's going to be on the negative part of the y-axis, therefore it will be negative. So now we just plug in, now since we set everything up, we just plug in any information we're given. So for the force of gravity, that's just mass times gravity. So it's mass times gravity, which is 9.8. And then that's why I got 15.778. And then it will equal the mass, which is 1.61. And then acceleration is actually, the formula is v squared divided by r, because it's in a circle. Since it's going around in a circle, it's actually going to have the uniform circular motion formula. So for that, all I did was just plug in the values, which are right here. I just plugged in velocity over the radius. So then what happens is you get, I just plugged all that, don't forget the negative sign, and then after all this multiplication, I got negative 46.368. Now just to cancel units, I just added on each side and got negative 30.59. Since both sides are negative, I just made it positive. And then don't forget that since it's a physics problem, you have to worry about sig figs. So since everything here was in 3 sig figs, the final answer has to be in sig figs. And since it's a force, it will be in newtons. Finally, since it's magnitude, means that it will be positive. Your final answer will be positive. So your final answer will be 3 sig figs. It'll be positive, and the units will be in newtons. I hope that helped, and thanks for watching.